About 2 years ago, I released what I claimed would be part one of a two-part series where I repaired a trio of broken Pac-Man arcade cocktail cabinets. I bought 3 of these with the intention of profiting enough off of 2 of them to get the third one for free for myself. But that all went astray when I hit a dead end on the third machine, and then I ran out of the vacation time that I had set aside for that project, which leads us to this video around 2 years later. But over those past 2 years, I did find time here and there to work on that third machine. But before we get into that, let's check up on the one machine that I kept for myself. I ended up running into a problem where, if I didn't use the machine for a long time, when I would turn it on, the monitor fuse in the cabinet would blow. Typically, I would consider this to be a developing problem with the monitor chassis, such as a component that's starting to short. But before I went that far, I took a look at the fuse I was using. A standard fuse works by blowing or opening whenever amperage higher than its rating passes through it. This protects all the wiring and components downstream of the fuse in the event of a short circuit, since a short circuit draws a lot of amps. The wiring diagram calls for a 1 amp slow blow fuse. A slow blow fuse will allow a higher amperage than it's rated for to pass through it, but only briefly. Turns out, a G07 monitor needs that type of fuse because it briefly draws more amps when it's starting up than it does when it's running and stabilized. And, being an ignorant person, I was just using a standard fuse, which blew instantly whenever that higher amperage tried to pass through it. After installing the right fuse, the machine works great. And I haven't had a problem since. So I guess you could say,
it was just a fuse!
Now that that's out of the way, we need to take a look at this third and final Pac-Man machine and lay this multi-year epic saga of arcade repairs to rest. Last time we saw this machine, there were signs that the cabinet had been on fire. I didn't even try to power up the monitor, and I couldn't get the circuit board to give me anything other than garbage on the screen. And since then, it's pretty much just sat here in the shop with all its different parts strewn across the whole building. So I threw everything back together, made up a new power cord for it, and got to work on that burning chassis. This chassis was absolutely filthy, both from the smoke and from sitting in a dusty workshop with a floofy cat. Rather than trying to clean this with rubbing alcohol by hand, I decided to try the water hose method I'd seen from other YouTubers. But first, I already know I want to replace a lot of the different parts on the chassis, so I went ahead and removed the flyback transformer and all the caps and resistors that I wanted to replace. That way the area underneath those components would also be cleaned. I then took the chassis outside, dumped some dish detergent on it, and sprayed the daylights out of it with a water hose. Honestly, I doubt this chassis has ever been so clean since the day it was new. It's so clean you can eat off of it. Afterwards, I let it sit under a fan for a few days before installing all my new components. One tip is that whenever I install a modern replacement flyback, I usually drill out the pads a little bit. It just makes everything fit a whole lot easier. After putting everything back together, I was glad to see that there was no more fire. Unfortunately though, the picture was partially collapsed, so I needed to remove the chassis again and troubleshoot it. I started off by removing the X401 and X402 transistors, as these are common points of failure that cause vertical collapse. I soldered everything in, reassembled the machine, and then that was the sound of a resistor exploding, which tells me that there's something in the circuit that's shorted out and is pulling way too many amps through that resistor. So at this point, I decided to pull one of my working chassis out to compare readings. I started by checking everything in the vertical deflection circuit between the two chassis, using the G07 flowchart for guidance. I followed everything along that circuit path, searching for whatever component was shorted out. If I found anything that seemed suspect, I would remove it and test it out of circuit to try to isolate the problematic component. I eventually came to the conclusion that the replacement transistors that I'd used were to blame. I determined this by putting the transistors from my Pac-Man monitor next to the ones from my Galaga monitor, and comparing readings. I found that the Pac-Man ones were getting a reading across these legs, but the Galaga ones were not, meaning that these legs were connected, or shorted, together, which would cause exactly the kind of issue that I had. So I replaced them again, but I was still getting the same vertical collapse issue from the monitor. Turned out, it was simply the vertical size potentiometer, which just took a little fiddling. Now the monitor looks great, but that leads me to my last problem. In the last episode, I tried my darndest to get this board working. I determined, via mikesarcade.com, that it was experiencing ROM and RAM issues, so I replaced all of both, to no avail. So now, I'm going to start narrowing down my variables by using my working Pac-Man PCB as a point of comparison. That board still works fine in the other cabinet, so I know that none of the cabinet wiring or transformers are to blame. From there, I broke out the Pac-Man schematic. This shows where every single component on the PCB connects to the other one in series. Over the course of several hours over several days, I traced every connection related to the ROM, RAM, Z80, and anything else I could think of, and compared any suspect readings to my working board. I found a few broken connections and shorts, but even after I fixed all of those, I still had the same problem. In an act of desperation, I broke out the logic probe. The logic probe is a cheap way to kind of vaguely understand what a chip is doing, based on whether it's pulling the voltage low or high. I took a couple readings on the working board, then checked the same component on the non-working.
Legitimately fell on the floor. I guess I should get up.
I did this for a couple of days, basically comparing readings across every single chip on the PCB. Anything on the broken board that sounded different from the working board got replaced, until, eventually, So from there, I methodically followed a similar path to the one before, checking each ROM chip, RAM chip, and its connection all the way back to the Z80. I replaced nearly every single ROM or RAM associated component on this board, time and time again. This cabinet took far more work than it was worth. Hundreds of hours. None of this was worth limited time on
this chip here,
on a stupid,
but I did enjoy the process. The incessant all the way down.
Probe, I'm sure
you
you'll
clearly see that there is A0 and 10 coming from the ROM.
I'm not going to none of this was what I'm saying. But I did enjoy the process. Every single ROM. I'm sure you'll understand
11 connections.
Wasting nearly what I'm saying distinctly About 2 years ago, I released what I claimed would be part 1 of a 2-part series where I repaired a trio of broken Pac-Man arcade cocktail cabinets. I bought 3 of these with the intention of profiting enough like 2 of them to get the third one for free. But that all went astray. So I broke down and just bought a working PCB from Clove and installed that in the cabinet. I then went on to do the same carriage bolt trick as I did before, and remove the broken bottom and replace it with casters, so the machine could be moved very easily. I also made a giant mess in the process, but I wasn't married yet, so it was okay. I hate living in the city. Okay, so the lighting and the audio and like everything's gonna be bad for this part because I'm in this ridiculously tiny garage and I'm trying to film a 2-camera part. I'm actually about to move out of here and I wanted at least one part to be filmed in this before I never see it again. Yes, after years of work and even longer of waiting, I can finally move on from this project and focus on other things. But what about my initial idea of getting 3 of the machines and selling 2 of them so that the third would be mine for free or close to it? Well, frankly, I've lost track of how much I've spent on these, and I only profited about $200 from the multicade, and I probably just broke even on this one that I just fixed. So in the long run, it probably wasn't worth it financially, but I do take some other things into account in regards to that. First off, I was able to save a lot of money on these by buying in bulk, so even if I broke even on the last one, I still saved a bunch of money on the one that I kept. And that little bit of profit did mean that my machine was a little bit cheaper. Second, each of these served as its own learning experience, and I'm a much better repairman now than I was before I started. And lastly, this served as the subject of one of the most popular Coin Out Corner episodes in the past, and one of the most anticipated ones in the present.
Nothing means nothing, and nothing is exactly how much content you produced this year, Jeremiah Jackson! Quit hiding in the coin-op corner and release those Pac-Man repair videos!
So all in all, I'm glad I took the plunge, but I certainly wouldn't do it again, and I'm gonna stay away from anything like that in the future. But that wraps it up for this climactic special part 2 episode of Pack Repair on Coin Op Corner. So head on to the spread shop and buy some shirts and some cups. I don't even think we have these in stock anymore. And yeah, thanks for watching. They would pick as soon as I start trying to record audio to like hammer on something out there. I get tired of this crap.